Okay, the first video that we're going to use this week is to continue to talk about the algebraic topic of linear functions. So the first thing that we need to discuss is the slope of a line that is formed on a graph. So the slope refers to the steepness of the line, and we do have a mathematical way of calculating that. But this slide is just going over the types of slope that you're going to come into contact with. So if it's a positive slope, it's increasing from left to right. If it's a negative slope, it's decreasing from left to right. Zero slope means that it's a horizontal line, and an undefined slope means that it's a vertical line. So we can find the slope of a line several different ways. So I'm going to go over those ways here on this slide and the next one. So first of all, you can think of slope as being rise over run. So if we have 2 points on a line, you can pick any 2 points on the line. It does not matter which two you pick. The rise refers to the vertical distance between the points, and the run represents the horizontal distance between the 2 points. So in this example, I see that I start at 1. Oops, sorry about that. I start at 1 and I go to 3. So if I were to count that difference or the boxes, I'd have to rise 2. So my rise for that first example would be 2 units. Looking at the run, I start at a value of 2 and I end at a value of 6. So again, that difference, or if I count the boxes, the run is 4. We would find the slope by taking the rise and dividing it by the run. We usually see the slope left as a fraction in reduced form. So the rise is 2, the run is 4, but if we wanted to reduce this, notice that they're both divisible by 2. So the reduced form would be 1/2. So this has a slope of positive 1/2. It is increasing as I move from left to right. Another way that we can find slope that actually means the same as rise over run is change in y over change in x. So the change in y, that is the same as saying the rise. How much do the y values change? Okay, it started at 1. It increased to 3. That was a change of 2, okay, or a rise of 2. Over here, if we look at the change in y, if we start at this top point, we see that we may have to move down 3 units. The change in y started at 5 and went to 2. So the change in y is -3 or -3 units. And then the run can also be viewed as the change in x. So again, if I look at these x values, this x value is starting at 0, and this x value is ending at 4. So the change in x is 4 units. We see that here. That change of 4 units could also be called the run, right? So we would see that we would run 4 units. So our change in x is 4. So these two ways of finding slope, they mean the same thing. The rise means how much are the y values changing, and the run means how much are the x values changing. On this second example, notice that we did get a negative slope, -3/4. Doesn't matter where you put that negative. You could keep it with the numerator. You could put it out front. You could put it with the denominator. You just can't put it with both. -3 divided by -4, that would actually make +3/4. This slope is not positive because it is decreasing as we move from left to right. Okay, so we see that there's 2 different ways or 2 different formulas that we could use to find slope here, but they actually mean the same. We're going to take a look at one more that again means the same thing, but it looks very different. Okay, this is another form that you might see slope in. This is more of a formula-based way of finding slope. It says take the second y value and subtract the first y value. Guys, that would still be the change in y, right? To find the change in y, we subtract the two y values that we have. And then to get the run, we would subtract the two x values. So x2 minus x1, that means the same as change in x. So all of these formulas, all of these different ways of finding slope, they mean the same thing. It's just different ways of viewing it. Okay, so with this one, we're going to use the formula. We can see that they already have the rise and the run labeled. So we can see that the rise is 2 and the run is 3. So we're supposed to get 2/3 as this slope. But we're going to use these 2 points and the slope formula to see that we do get that same answer. So this point is located at -1, 1. I'm going to call that my first x value and my first y value. This point here is located at 2, 3. I'm going to call that my second x value and my second y value. Okay, so the formula says I take the second y value, which is 3, and subtract the first y value, which is 1. I divide that by the second x value, which we said was 2, minus the first x value, which we said the first x value was -1. Watch those signs, guys, minus a negative. Okay, so if we do that, 3 minus 1, that gives me 2. And 3 minus a -1, that actually means plus. So 2 plus 1 gives me 3. We can see that the rise is 2 and the run is 3. We got the same thing using that formula. So again, just to reiterate, all 3 of these formulas mean the same thing. They're all different ways of finding slope. So whichever way you like best is how you can do it. Okay, so we're going to do a practice problem, again, finding slope. You could do this any one of the 3 ways, and I encourage you to pick a way, try to find the slope, pause the video here, see if you can find that slope, and then unpause the video to get the answer. Again, I will show all 3 ways. Okay, so the first way I'm going to show, pause the video here if you haven't tried it yet, and then unpause when you're ready. The first method that I'm going to use is probably the most popular one, the rise and the run. Okay, so notice I'm starting at the bottom point. I rise and I figure out how many units I have to rise. So 1, 2, 3, 4, 5, 6. I'm rising 6 units. And then I have to figure out how many do I run. But notice I am running to the left. That is going to be negative. Start here and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm running 10 units to the left. So my rise over my run is rise of 6. Run is -10. That does reduce. They will divide by 2. So that gives me 3 over -5. Remember, that negative sign can go anywhere. So I usually put it out front and just say -3/5 is my slope. And m is the variable that we use to represent slope, in case I didn't mention that before. Okay, so I just used rise over run, which is a very popular method. Now I'm going to talk a little bit about the change in x versus the change in y. And making sure change in y is the numerator and change in x is the denominator. So if we look at the y values, this y value is 3, this y value is 9. So that's a change of 6. Okay, and then here, the change in x, 12 and 2, that's a change of 10. If you're using this change in y over change in x, really have to be careful of whether the line is increasing or decreasing. As I move from left to right, I see that this is decreasing, so I need to make this a negative. Again, it reduces to that same answer that we got earlier. Okay, so caution when you're using change in y over change in x. Always double check your sign. Make sure that if it's a positive, it's an increasing from left to right. If it's negative, it's decreasing as we move from left to right. Okay, and then the last method that I'm going to show here is, again, the formula. I'm going to label these 2 points. I'm going to call this point my first point, x1 and y1, and this point my second point. So this is x2 and y2. Okay, the formula says we take y2 minus y1 and divide it by x2 minus x1. My second y value is 3 minus my first y value of 9 over my second x value of 12 minus my first x value of 2. 3 minus 9 gives me negative 6. 12 minus 2 gives me 10. And again, we reduce to the same answer, negative 3/5. Guys, I get that same slope no matter which method I use. Again, you just have to see which one you like best and stick with it. Okay, so now we're going to start to talk about graphing lines, and specifically we're going to be dealing with what's called slope-intercept form of an equation, which looks like y equals mx plus b. We just talked about m. M is the slope. And then b stands for the y-intercept. Okay, so we're going to practice graphing some lines that are in slope-intercept form. Okay, so the first one I'll put in blue. I might graph 2 of them in different colors and then erase to do the next 2, just so it doesn't get too busy on this coordinate system. So if we take a look at this equation, y equals mx plus b, we can pick out what is the slope and what is the y-intercept. The value that's in the m spot is the slope. So this is telling me the slope is 1/2. And the value that's in the b position, that is the y-intercept. Okay, so when you're graphing, you're always going to start at the y-intercept value. The y-intercept means that's where it touches the y-axis. So I'm going to go over to the y-axis, and I see the y-intercept is 3. So I'm going to mark 3 on that y-axis. Okay, then you can use the slope to get to the next point. Again, if I think about that slope as being change in y over change in x, or rise over run, those are probably the 2 most common ways to think about it. My rise is 1, so I'm going to go up 1, and my run is 2, so I'm going to go right 2. So this is positive, positive, so up 1, right 2. Now, I could continue to rise 1 and run 2, get as many points as I want on the line. Now, also remember that negative divided by negative does make a positive. So instead of moving up and to the right, I could move down and to the left, and I should still be on that same line. Okay, I would connect those points in a straight line, and there is my graph. Okay, so there is our line for y equals 1/2 x plus 3. I'm going to change colors so that way we can tell the difference between that one and the next equation. We're going to graph y equals 3x minus 1 in this pink color. Okay, so looking, Our slope is 3. It might be helpful to write that as a fraction. So remember to make a whole number into a fraction. We would just stick it over 1. And our y-intercept is -1. Okay, so we start at the y-intercept, -1, and our slope is 3/1. So the rise is 3, and the run is 1. So I'm going to go up 3 and over 1. And again, we can continue to go up 3 and over 1. Also, we could put -3 divided by -1. That is still a positive 3 slope. So I could go down 3 and left 1. Again, ensuring that they're all in a single line, which they are. It's going to be probably hard for me to connect these in a straight line. I'm going to do my best. There we go. So there is my linear function for y equals 3x minus 1. Okay, I'm going to clear this slide. And so the last 2 examples we can put on there, and it's going to be a little cleaner. Okay, so number 3, I'll graph that one in red. We have y equals -2/3 x minus 2. Our slope is -2/3. And our y-intercept is -2. Okay, so we start at the y-intercept of -2. And then my slope is -2/3. So I could put that negative sign with the numerator or with the denominator, but not both. Okay, so if I'm thinking -2 over +3, my rise would be -2. That would actually mean I'd move down 2. And my run is +3. So that would be to the right 3. Now, if I wanted to, I could put the +2 and the -3. So the rise would be +2, so I'd move up 2 this time. But my run is -3, so I would move left 3 units. Again, ensuring that they're all lying on the same line, which they are. Connecting those points in a straight line as best you can. That was pretty wavy, but the best I can do on this little slate. Okay, the last example that we're going to take a look at, I'm going to put it in blue. We have y equals -2x plus 4. So -2, sorry, that's hard to read now that I drew right through it, is the slope, and +4 is the y-intercept. So I'm going to start by marking the y-intercept at +4. My slope is -2/1, or I could put the negative sign with the denominator instead. So I'm going to go, if my rise is -2, that's down 2. My run would be +1. And then, or I could do +2 as the rise, and then -1 as the slope. Sorry, that one's off the graph, but you can see that they are still falling in the same line. I'm going to go down 2 and over 1 a couple more times to hopefully make it easier to draw my line, but I am not good going in this direction. Oh, that one wasn't bad. Okay, so there's number 4. Okay, so guys, to recap, when we're graphing lines, we always start at the y-intercept and then use the slope to get to the next point. And again, the easiest way to do that is the numerator represents the rise, the denominator represents the run. If it is a whole number, just stick it over 1, make it a fraction. Okay, we should also be able to graph a line, a linear function, from a point and the slope. Okay, so a couple of examples. I'll put this first one in blue. We have the point -2, -4. Let's go ahead and mark that on our graph first. The x value is -2, the y value is -4, so there's my point. We know the slope is 2/3. So that means the rise is 2 and the run is 3. So I'm going to rise 2 and run 3. I'm going to continue. Rise 2, run 3 to make it easier to draw that line. I am much better drawing positive lines than negative ones. Okay, let me switch colors and repeat that process. So let's say we have the point at -4, 3. And our slope is -2. I'm going to stick that over 1 to make it a fraction. So my rise is -2 and my run is +1. So I'm going to go down 2 and +1 to the right. Again, I'm going to mark a couple more points, down 2 and over 1, down 2 and over 1. I could also go up 2 and left 1 to stay on that line. Connecting these in a straight line-ish. There we go. All right, I'm going to try to fit all 4 of these on one graph. We'll see how it looks in just a minute. Okay, so the next one, we have a point at 3, 0. So 3, 0 would be to the right 3. We do not move up or down at all because the y value is 0. We have a slope of -1. Again, I'm going to stick that over 1 to make it a fraction. So my rise is -1 and my run is +1. So rise of -1 means we move down 1 to the right +1. I could continue down 1 and right 1, or I could put that negative sign with the denominator. So it'd be +1 over -1. That means the same. My rise is now positive, but my run is negative. So up, +1, left, -1. Notice that's still on that same line. So up 1, left 1. Okay, here is my line for that third example. Okay, the fourth one, let me change colors, and maybe we'll go with that's kind of close. Go with red or orange. Okay, we have a point at 2, -2. 2, -2. And our slope is 3. So I'm going to stick that over 1. My rise is 3. My run is 1. So I'm going to rise 3 and run 1. Mark another one. Again, I could make those both negative, down 3 and left 1. It's still part of that same line. Let me see if I can connect those, and there is my linear function. Okay. That concludes our algebraic lesson for today.